Hello friends, in today's video we are going to see the next topic in our Stream API, that is mapping and collecting. So what is mapping? Often it is useful to map the elements of one stream to another stream. Okay. So there are two streams available. We are going to map the elements of one stream to another. For example, in left-hand side stream, there are database of name, telephone, email address, suppose, for example, and that might map only the name and email address to another stream of the right-hand stream. Or you want to apply some transformation, transform the element. For this, you can map the transformed element to a new stream, that is right-hand stream. Fortunately, Stream API provides built-in support for these common operations. The most general mapping method is map method. Here, R stream R map function, wildcard super D extends R map function. Here, R is the type of elements. T is the type of elements of the new stream. T is the type of element of the invoking stream. And map function is the instance of function which does the actual mapping. Okay. So you have to remember, please write down the syntax of the mapping method that is very generally commonly used. As suggested, map function must be stateless and non-interfering, whose explanation I have given you in the previous session. Since a new stream is written, it is not terminated. Map is an intermediate method. Function is a functional interface provided in java.util.function package and declared like function t, r. So there is one abstract method in the functional interface r apply t value. R is mapped result, value is the reference to the object being mapped. Now we will see the simple example of mapping. The program name is map one stream to another stream name. For this, map package mapping is created. Map one stream to another demo project is created. Here is a Java file. Two packages are imported. Stream is important for Stream API. Util package for array list. Here double values are added as the previous example. 7, 18, 10, 24, 17 and 5 are the numbers added to the array list, that is my list. Okay. Map the square root of elements in my list to a new stream. So they will be interconnected now. Stream double square root stream is created. Map A to match square root of A. Find the product of square root stream. Here we are mapping. Okay. And square root products will be created. Okay, identity value is 1.0 and square root will be A into B square root product. And product of square root is displayed over here. Now I will run this. This is 1603.2467. Okay, so you have to write this down or take a screenshot. So next, program computes the product of square root but using map. Square root of elements are first mapped to a new string and then reduce will do the appropriate operation, that is computing the product multiplication of square root, and output will be same as the previous version. What is the difference between this version and the product of square root in the previous example, in the previous session we saw? The difference is that transformation occurs during mapping rather than during the reduction operation. So directly, other than using the combiner function version of reduce, we can directly use the two parameter format of reduce like we have seen in the previous session. There are two formats. One is using combiner to combine the product and only two parameter format of reduce. Okay, no need to combine. Now we will see the example that uses map to create new string that contains only selected fields from the original string, name, phone, email, which contains name, phone numbers and email addresses. Then maps only the names and phone numbers to a new string. Okay, only the selected elements and email addresses are discarded. This is the program project name, phone, email. Here three parameterized constructor is created, name, phone number and email. While creating object of this type, you will be passing the values. Okay, those will be instantiated into name, phone number and email. New class is created for only name and phone number. Two parameters as constructor, only name and phone number. List of name, phone number, email. Three parameterized constructors are called original values. Okay, mylist.stream for each value in the stream we are printing name, phone number and email. Then map just name and phone numbers. Mylist.stream map A to name and phone number only. Email address is not taken over here, so only it will display name and phone number. Okay, so now I will run this one. Email ID will not be displayed. Okay, so only name and phone numbers are given. Email ID are not taken because mapping is done only for name and phone number. Okay, you can pipeline more than one intermediate operation. One operation creates another operation, other result. That result will create another intermediate operation. Like this, you can easily create very powerful action to produce a very great result. The following statement uses filter and then map. First filter and then map, and then produce a new string that contains only a name, phone number, whose name elements with the name J. So filter is applied where name equals J, map to only name and phone number. And this type of operation is very common when creating database style query. When we will practice more, you will find that the chains of operation can be used to create very sophisticated queries, merge and selection on a data stream. Only you need to do what? Practice more and more. After this version, 3 more versions of map are provided. They return a primitive stream, int stream, log stream, and double stream. Int stream map to int function, wildcard super T map function, log stream map to long function, super T map function, double stream map to double super T map function. Each map function must implement the abstract method provided, like to double function specifies one abstract method apply as double, which must return the type double. Now we will see the example that uses a primitive string. It first create array list of double values, okay, and then uses stream followed by map to int to create int stream that contains ceiling of each value. Okay. First of all, it will create an array list of double, then uses stream followed by map to int. Ceiling of each value. So the third program is map stream to int stream. Okay. So let's see this program, map stream to int stream. This is the program project created. Package stream to int stream is created. This is the Java program. Here, two packages are there. util stream. These values are added to a double 1.1, 3.6, 9.2, 4.7, 12.1, 5.0. Original values are displayed in system.out.println, and then ceiling values are displayed using map to int mylist.stream map to int a to mat.ceil of a. Ceilings of the values now we will display in the output. Okay. Upper bound value of 1.1 is 2, 3.6 is 4. Okay, so directly those are mapped. What are ceiling values? The values very near to the double values. Whole number, real the pointed double number. That is 1.1. The upper value is 2, like this. Okay, so this is the output. You can write down the program or take a screenshot as usual. Okay. So next. Now, the stream produced by map to int contains the ceiling values, the uppermost whole number value. The stream API also provides method for flat map. The flat map methods provided are flat map to int, flat map to long, flat map to double, are designed to handle situations in which each element in the original stream is mapped to more than one element in the result stream. Okay. So directly only one-to-one mapping is not there. One-to-many mapping is provided in the flat map. And after, if you are using Java 16 and above, then you can use these following methods: map multi to int, map multi to long, map multi to double. These are flat map related methods. The next topic is collecting. We have seen in the previous examples, it is possible and very general to have stream from collection, or vice versa. In certain situation, we want to obtain a collection from a stream. To perform this, you will generally use the collect method, collection from a stream. Okay, there are two forms of this. One we will use here, R collect, collector super T A R collector function. Here R is the type of the result, T is element type of the invoking stream, and internal accumulated type is given by A. Collector function specifies you how the collection process works actually. And collect method is a terminal operation because it collects as a collection of data. Collector interface declared in like this, collector interface TAR. Okay, so TAR meanings are same as the previous PPT. There are several methods available, but we don't need to implement all of them. Okay, for the sake of our chapter, our understanding of this chapter. Instead of that, we will use two of the predefined collectors available provided by collectors class, which is packaged in java.util.stream. Okay. Collector class defines a number of static collector methods. And in those static collector methods, those can be used without the collector object. Two of them are static toList and static toSet. Okay. So what is the syntax of static toList? Static T collector T wildcard, then list T toList, static T collector T wildcard set T toSet. The toList method returns a collector that can be used to collect elements into a list. Okay, all elements will be collected to a list, and toSet method is used to collect elements into a set. Okay, so how to use it? Like call the collect method like below, collect collectors to list. So all the elements will be collected to the list. Okay. Now we will see the example in practice. It will have the same example, that is no name, phone, email we have seen. It collects the name and phone numbers into list and a set. Okay. Name, phone, email. Okay. Package name, phone, email again is created. Name, phone, email again .java. Let's see one by one. Util and stream package is created, imported over here. Stream devo 7, 3 parameters as seen in the previous example. Name, phone number, email, and the second class name, phone number, having only 2 parameters, name and phone number. Okay. So the third thing is addition of name, phone, email, and now map just names and phone numbers to a new stream using the map method as usual in the previous example. Now this is the list of name and phone using the class that we have created as name, phone. Name and phone collect, it will give you the list. Collectors.toList. Collect method, inside the collect method we are passing collectors.toList. So here list object will be created, NP list, and for each NP list key object of name, phone, we are displaying name and phone. Okay, names and phone numbers in a list and mapping A to the new name, phone. Okay, Then set np set collect collectors dot to set. So it will give you the set of the np set. So for each np set of e object, we are displaying e and phone number, name and phone number. Okay. So email ID is discarded as previous. Output is same. Email ID is discarded in list also and set also. Okay. This is very simple exam, just a tricky. So you have to understand these two lines. If you understand these two lines, the program is very similar to the previous. Okay, and you already know how to write this type of for loop to display the list elements and the set elements. Okay, just understand these two lines. List object is equal to name and phone stream dot collect collectors dot to list, and name and phone stream dot collect collectors dot to set. Okay, write down this program. Okay, here we have obtaining the another mapping of names and phone numbers. Here name and phone. Okay, this is the second mapping. This is the first mapping. Object name is same, but for the second time we are doing the mapping to have the object name and phone as a mapped object, stream object. Okay. Okay. Following line collects to list name phone np list and name and phone stream name dot collect collectors dot to list. Okay, collection refer to np list can be used like any other list collection as we have used in the collection chapter. It can be cycled like in a for loop for name for each and every object in np list. We are displaying name and phone number. The creation of set via collect, same way. So it is very powerful action we have understood now. Move data from collection to stream and stream to collection. It is very powerful attribute of the stream API that we are learning right now. What are the advantage of this? You can write them down. It gives you the ability to operate on a collection through a stream, but then repackage it as a collection. Okay, we can operate on a collection through a stream, but again repackage it as a collection again. And if you are appropriately using the stream, if you are practicing more at home, if you understand each and everything in a stream API, you can also execute it parallelly in your parallel multi-core processor. Okay, so that it will speed up your execution. Also, it will save your time. Okay, so first of all, you can create a stream and operate on the collection through a stream, and again repackage it in a collection object. Okay, write down and understand these two things. The version of collect used by previous example, collect, call collectors dot to list and to set is very much convenient and often the one you want. And but there is one another version given by collection. R collect, supplier, R target, by consumer, R wildcard, super T, accumulator, by consumer, RR combiner. Here target specifies how the object that holds the result is collected. Okay, is created. Sorry, target will give you how the object that holds the result is created. To use a linked list, you will specify its constructor. The accumulator function adds an element to the result and combiner combines two partial results. Okay, so it will work the same way as the reduce operation. But you have to understand, must be stateless, non-interfering, and associate. Okay, these three things you have to remember. Those must be stateless, non-interfering, associative. The target is a type of supplier. Supplier is a functional interface provided in package java.util.function. Only one abstract method, get method, default method, no parameters returns, and in this case it returns object of type R. So as it relates to collect, it returns reference to a mutable storage object like a collection. Okay, so get will give you the mutable collection object. The abstract method provided by supplier, and supplier is a functional interface in a java.util.function. The types of accumulator and combiner are by consumer. By consumer is a functional interface defined in java.util.function as well. Okay, only one abstract method abstract is provided with two parameters t object, u object 2. So this method performs some type of operation that is accept on object 1 and object 2. So as it relates to accumulator, as object specifies the target collection and element to add to that collection. That target collection will be specified by object 2. Object 1 and object 2 specify two collections that will be combined together. Okay. Now we have seen one version of collect. You could use a linked list as the target in the preceding program. Linked list of name and phone collect. New linked list. First the lambda expression. List element, list dot add element, list A, list B, list A dot add on list B. Okay. First argument is a lambda expression that returns a new linked list. And second one uses the standard collection method, that is list dot add element, list A, list B, list A add all list B. So all list B elements here will be added to list A. Okay. And these elements will be added one by one. The third element uses add all to combine two linked lists. List of elements, add elements one by one, list A, list B, add all elements from list B to list A. You can use any method defined by linked list to add an element to the list as you require, as you like. So you can add first method to add elements to the start of the list element, list dot add first element. Okay, so element will be added to the start of the list. It is not always necessary to specify lambda expression. Often method and constructor references will be sufficient. Okay, the lambda expression is optional, not compulsory. Again, assuming the preceding program has set example is given following that contains all the elements in name and phone string. Name and phone dot collect has set new, has set add, has set all. Okay, new object is created, elements are added. First argument specifies the hashtag constructor reference. The second and third references to hashtag add and add all methods. Okay, collect method performs what is called as a mutable reduction. Okay, so mutable means changeable. Result of reduction given by collection is always changeable. Storage object such as collection. If you don't want to change the collection, you can give it as unmodifiable collection. to have unmodifiable collection, first thing you have to remember that you have to use JDK 16 and above. Before JDK 16, it is not possible to have unmodifiable collection object. Okay. And second thing, you have to use toList method given. That toList will give you the unmodifiable collection object. It returns the unmodifiable list. Okay, so this way we have understood two new topics in our Stream API. First is mapping and second is collecting. Okay, in the next chapter, next session, I will try to cover all the topics remaining in this chapter. Till then, you can go back and revise. If you have not understood anything, please try to understand theory first. Please try to do these programs given on your own and understand line by line. Do not by heart them. Try to type them on your own. When you will stuck in between, when you will have error in between, so that you will understand where you are wrong. And when you will be wrong at some time, then only you can learn. If you will not do anything, if you will not do practice anything, then it is not possible to learn and improve. Okay, so I recommend in my each and every session, please go back and revise and please do practice as much as possible. Okay, to be master in Java programming. So meet you in the next session with new interesting topic in the Stream API. Thank you so much.